Hi, welcome to the Robotics channel. I'm Nelly. Today I would like to introduce you to a very valuable tool called Visual Components. Have you heard about Visual Components? Visual Components is a 3D simulation software for visualizing and analyzing production solutions in various industries. There are three techniques that can be used for creating simulations. There is process modeling, robot programming, and Python programming. Today, we will be focusing on process modeling because it is the most useful, fast, and easy feature in Visual Components. What it can do is visually create products, processes, and process flows in a form that is clear, straightforward, and quick. With its quick simulation setup, this feature streamlines the process of creating a simulation from layout planning to layout optimization. In this video, we will walk through some process modeling examples, understand process modeling concept, and a short video on simple simulation involving process modeling. Here are examples of process modeling simulation. It can be used for simulation of various industries' process line. Manufacturing operations are often very complex, and simulation can help to analyze the bottlenecks and visualize day-to-day operations. Robots, mobile robots, and humans can be easily set up for their operation as most of the setup are automatically configured by Visual Components. Next, the process modeling workflow. First, in process modeling, design the layout. The physical layout of the production system can be designed with more than 2,600 of simulation-ready components from e-catalog. The second step is to define the products. A product is an entity that flows through processes in the layout. You can configure and manage the product flow group, product type name, and product properties from the product type editor. Keep in mind that the product should be renamed to avoid confusion. The third step is to define the processes. A process is a representation of a machine, workphase, inventory, buffer, or other production step. The process editor is used to create processes from process statements. Machines can be programmed to behave like their real-life counterparts using routines and statements. Once we have finished defining the processes, it is time to define the flow. A flow is the sequence of processes that products go through in a production system. Products in process modeling are classified into groups based on the path they take during the simulation. We can define flow groups and production flow for each product through Process Flow Editor. The simulation is now ready to run after we have finished configuring the flow. A simulation can be created in a short amount of time by following the workflow. Workflow aims to get users to easily create their simulation. Hence, it is convenient for simulation experts or beginners. Let's watch this short video to get an understanding on how process modeling workflow is applied. The first step, design the layout. Components should be placed in the correct position and orientation, and station, walkways, buffers, and spacing requirements should all be considered into the design. At this point, I arrange the components following the layout plan. dragging the component from e-catalog to add them into the production 3D world. The color of the component can be changed. The second step, define the products. In this phase, products that go through processes are defined. Adding new product into the flow group. Here, I am defining the product and change the name to avoid any confusion while preparing the simulation. The third step, define the processes. Before defining processes, it's important to consider how products should develop during production. Then, we need to define the production steps for each process. The fourth step, define the flow. Products are defined in groups based on the path they follow during the simulation. You are able to define the transport links, which determine how products are moved between two processes during the simulation. The final step is run the simulation. Visual Components is a user-friendly tool. Its simulations are set up with easy and simple to use workflow and ready to use 3D models from its library. Process modeling feature allows users to manage process flows without requiring complex programming. As we know, time is money and creating a simulation also consumes time. But process modeling allows us to create simulation in a faster yet accurate method. Comparing to a physical proof of concept, a 3D simulation can greatly reduce the cost as the layout are built in a virtual environment. 3D simulation provides a clearer visualization on the production solution. Even better, Visual Components can export the production flow as a video for analysis or concept proofing. Finally, we are getting to the end of today's sharing video. I believe you can now see how useful and powerful Visual Component is, especially when it comes to simulating processes. The process of creating simulation is convenient for any users because all resources such as robots, mobile robots, and humans are pre-set up and available directly from e-catalog. Users don't need to spend much time configuring them. You can create your own simulation even if you have no experience with Visual Components or only with minimal technical knowledge. Another benefit is that it is flexible. We are not only limited to use process modeling in Visual Components. For complex processes, we can combine with other techniques such as robot programming and Python programming to create complex processes. Thank you for taking the time to listen to me, and I hope you enjoy it. Do contact us and visit us on www.rorobotics.com for further explanation or any questions. We will provide you free demonstration upon request. Bye-bye!